Simplifying rational expressions. A rational expression, ratio. We're really talking about fractions. So the methods we're going to use to simplify our rational expressions are exactly the same as the ones we use to simplify fractions. Let's take an example. If you're adding two fractions, what you need to do is get yourself a common denominator. So we need a denominator that 5 and 7 both go into. So what we do is multiply this one by 7 over 7 and this one by 5 over 5. Then our two denominators are both going to be the denominator 35. You might want to ask yourself, why are you allowed to multiply by 7 over 7 and 5 over 5? And the answer, what does 7 over 7 equal? What does 5 over 5 equal? And if you multiply by 1, does anything change? No. Things look different, but they have the same value. Let's keep going. Let's do the math. 2 times 7 would give us 14 over 35. 4 times 5 would give us 20 over 35. As soon as you have the same denominator, you just add the numerators. Let's do the same thing with a rational expression. So what did we do? We found a common denominator. We looked at the denominators. We said we need to have this in this denominator. So what do we need here that we don't yet have? What do we need here that we don't yet have? So we're going to multiply by x plus 1 over x plus 1 and x plus 4 over x plus 4. That way, our denominators are going to be the same. And all we've done again is multiply by 1, so nothing has changed. 1 times x plus 1, 3 times x plus 4. Then we'll multiply that out. That becomes 3x plus 12, and then we combine our like terms. We have 3x and x to give us 4x, 1 and 12 to give us 13. Now make sure you specify all the things that x is not allowed to equal 0. Anytime we had anything in the denominator, we are not allowed to have a 0 in the denominator. So for this one, we can't equal -4. For this one, we can't equal -1. Why did we not have to do that over here? Because there's no x. So there's no way to make that denominator 0. So quick recap, if you are adding or subtracting, you must find a common denominator. So you multiply top and bottom by those denominators so that the denominators look the same. Then do some good math. What if you're multiplying? We're multiplying 1/2 by 2/3 by 3/4 by 4/5. When you multiply fractions, you multiply the numerators and then you multiply the denominators. So this is our numerator and this one is our denominator. So multiplying the numerators, you multiply 1 by 2 by 3 by 4. Multiply the denominator, 2 by 3 by 4 by 5. We get 24 over 120, and I think you can divide those. I think 24 goes in there once and 5 times. So our final answer is 1 over 5. So we're reducing to get 1 over 5. And your question you want to ask yourself, I wonder if there's a smarter way to do this. We multiply and we have to reduce. What if we did it the other way around? Let's start again. What if we reduced first and said there's a 2 in the top and the bottom that will reduce, a 3 in the top and the bottom that will reduce, and a 4 in the top and bottom that will reduce? What do we get now? Then we just get 1 times 1 times 1 times 1 in the top, because when you divide by 2, it goes once. When you divide by 3, it went in once. When you divide by 4, it went in once. We're going to end up with the same answer. So it looks like rather than multiply and then reduce, it's easier to reduce and then multiply. Let's do the same thing over here. Ooh, this looks a little more complicated. These aren't actually multiplied together. Ooh, I bet we could factor. That looks better. Now things are all multiplied together. So difference of squares on this one. Trinomial factoring over here. And now we see all kinds of things that we can reduce. So things must be multiplied together if you're going to reduce them. Don't you dare try getting rid of those. If you're going to reduce, it has to go into every single term. And terms are separated by plus or minus signs. So this is actually considered one term because it's multiplied together. That's why you're allowed to say we can reduce those. So again, factor so that things are multiplied, then we can reduce. Those will go in once These will go in once. What a great question this is. What are we left with? A whole bunch of 1s and a 2, so our final answer is a half. And again, if these terms are going to be algebraically equivalent, you must specify any restrictions, because a half is not really the same as that. A half is the same as that if you say that x cannot equal 5/2 from here, 4 from here, and -5 from here. So what did we do again? We reduce first, and then you simply multiply the numerators and denominators. And please do it in that order. Reduce first. That's the number one thing you do, because then it keeps everything smaller. What if we're dividing? If we take 5/4 divided by 15/6, it looks like this. If we could get a number 1 in the bottom, we just have a fraction in the top. That would be easier. So we could even multiply this by, so we end up with 1. Well, if we multiplied by 6/15, that would just give us a 1 in the bottom. Now, why do we have to do the same thing to top and bottom? It's because 6/15 is not 1, but 6/15 over 6/15 is 1. So that's why we had to do the same thing to top and bottom, because that gives us 1. All right, what else can we do? I bet we can do some more reducing. 5 would go in here once and 3 times. Divide this by 2 and this by 2. All right, what are we left with? Oh, and we can reduce this, can't we? So our final answer is a half. And this is known as multiplying by the reciprocal. So what we did in order to get 1 on the bottom is we looked at this fraction and said if we multiply by the reciprocal, as in the turned upside down fraction, we'd end up with 1. So I wonder, can we do this quicker? We know to do this, we need to multiply by the reciprocal. What if we just do that right away? So instead of dividing, we just say we're going to multiply by the reciprocal. What happened to the bottom? Well, we know the bottom's 1, so why bother doing it? And then this is just much quicker. Then you get to the reducing stage a whole lot faster. And that will give us a 2 and a 3. And we get a half times 3/3, and that's just 1. So final answer, a half. So when you're dividing by a fraction, you say instead of dividing by the fraction, we are going to multiply by the reciprocal. The reason we do that would essentially give us 1 in the bottom, and we just don't bother showing that. All right, here we go. And again, we can't reduce anything unless it's all multiplied together. So let's start by factoring. This looks like a trinomial, and this looks like a common factor. All right, we're dividing by this. So what we're going to do is multiply by the reciprocal. How did we get it? We just turned the fraction on its head. Now look for things that you can eliminate. Let's see, I have an x minus 2 on the top and bottom, so that'll go in once. We have an x minus 1 on the top and bottom, that'll go in once. And I think that's it. So we're left with 3x over x plus 3. Now let's look at these restrictions. If anything was ever on the bottom, can't equal 1. What can we not equal there? What would make that equal 0? That's where the 0 comes from. So we've got our 1, we've got our 0, and then we multiply by the reciprocal, we get new terms on the bottom. So we can't equal 2, and we can't equal -3. So if any expression was ever in a denominator, it is not allowed to equal 0, and you have to list all of them. All right, your job today, you're on page 17, lesson 4. Get these exercises done so that tomorrow is going to be a good day for you.